Hello everyone, welcome to Numeric Ninja. Today we are going to discuss a problem which is taken from EGMO 2019, which is as follows. Find all real triples A, B and C such that both these conditions over here are satisfied. Now, the first thing that comes to my mind when I look in this problem is to treat this problem as solving some equations involving the variables A, B and C. And the general strategy to solve the equation which involves three variables is to reduce those equations and get a relation among any two variables. And here we are going to do the same thing. We're going to try to deduce a relation among A and B, which is independent of C. Now to do so, I'm going to take this pair, that is A square B plus C is equals to B square C plus A. Take A to the left hand side and C to the right hand side, and we get that A square B minus A is equals to B square C minus C. This is nothing but A times AB minus 1 equals to C times B square minus 1. Now, we are also given the equation that AB plus BC plus CA is equals to 1. From here, I can say that AB minus 1 is equals to minus BC minus CA. Take 1 to the left hand side and BC and CA to the right hand side. This is the same as minus C times A plus B. So from here, I can replace AB minus 1 as minus C times A plus B. So when I replace it, I get A times minus C times A plus B equals to minus C times 1 minus B squared. Take minus common from this term. Now from here, I can say that C is equals to 0, or we can say that A times A plus B is equals to 1 minus B squared. Now, let's first assume or suppose that C is not equal to 0. Then we can say that A times A plus B is equals to 1 minus B squared. It's nothing but A square plus AB plus B square equals to 1. Simplify this and take B minus B square to the right hand side. Sorry, to the left hand side. Now, if I assume that none among A, B, and C is equal to 0, then we can say that C square plus BC plus B square must be equal to 1, and A square plus AC plus C square must also be equal to 1, because if I perform the same steps on the pair AB as on the pair BC and CA, I will get the same thing. We just need to follow the same steps that we have done on the pair A and B to deduce these two relationships. Now, we are also given that A square B plus B square is equals to 1. If I add these things up, then we get that 2 times A square plus B square plus C square is actually equals to 3 minus AB plus BC plus CA. Adding this up, take AB plus BC plus CA from the left hand side to the right hand side. Now we were already given that AB plus BC plus C is equals to 1. So we can say this is basically 3 minus 1, which is equals to 2. Hence we can say that A square plus B square plus C square is equal to 1. Now, interestingly, that A square plus B square plus C square is equal to 1, which is equals to AB plus BC plus CA. Now, from here we can say that A square plus B square plus C square minus AB minus BC minus CA is equals to 0. Now, if we multiply 2 on both the sides, then we see that 2 times A square plus 2 times B square plus 2 times C square minus 2AB minus 2BC minus 2CA is equal to 0. If I split these terms up and write A square minus 2AB plus B square plus B square minus 2BC plus C square plus C square minus 2AC plus A square equals to 0. Now, A square minus 2AB plus B square is actually A minus B whole square. b square minus 2bc plus c square is actually b minus c square, and c square minus 2ac plus a square is actually c minus a square. That means that a minus b square plus b minus c square plus c minus a square is equals to 0. Now, since a, b, and c are all real positive numbers, sorry, not real numbers only, then we can say that a minus b, b minus c, and c minus a must also be real numbers. And sum of squares of real numbers can only be equal to 0 if and only if individually all of them is equal to 0. That is, a minus b is equals to b minus c equals to c minus a equals to 0. That is, a equals to b equals to c. Now, if I substitute this in the equation a square plus b square plus c square equals to 1, we get that 3a square is equals to 1 because we know a equals to b equals to c. Hence, we get that a square is equals to 1 by 3. That is, a is equals to plus minus 1 by root 3. Hence, one of the values for the pair a comma b comma c is 1 by root 3 comma 1 by root 3 comma 1 by root 3, and another pair is minus 1 by root 3 minus 1 by root 3 and minus 1 by root 3. Now we need to consider the cases when a, b, c, when these variables become 0. Now let's copy this equation here. AB plus BC plus C is equals to 1 and paste it. Now in this equation, if any two variable, say A equals to B equals to 0, if any two variables becomes 0, then we can say that AB will become 0, BC will become 0 because B is present, and CA will also become 0 because A is present. Hence, AB plus BC plus CA will become 0 when it is given in the question that is actually equals to 1. Hence, we get a contradiction. Hence, two variables together cannot be 0. Hence, only one variable can become 0 at any particular time. So, without loss of generality, let's assume that C is equals to 0. Now, if C is equals to 0, then the equation AB plus BC plus CA becomes only AB, and this is equals to 1, and this is actually A equals to 1 by B. Now, we are also given this information that A square B plus C is equals to B square C plus A equals to C square A plus B. Now, in this equation, if we take up the last two pairs, that is B square C plus A is equals to C square A plus B, and if we put over here that C is equals to 0, then we get C equals to 0, we get A equals to B, because this term becomes 0 and this term also becomes 0. Hence, we get A is equals to B and A is equals to 1 by B. Hence, the only solution of A is 1 or minus 1. Hence, we can say that A, B, C can be 1, 1, 0 or minus 1, minus 1, 0. And we can take any combination of these terms. That's, we can take 1, 0, 1, or we can take 0, 1, 1, and so on. We can take any combination of these terms. Hence, the final answer to this problem over here is 1 by root 3, comma 1 by root 3, comma 1 by root 3, minus 1 by root 3, minus 1 by root 3, minus 1 by root 3, 1, 1, 0, and any combination of this, and minus 1, 0, and any combination of this. I hope you enjoyed the video. If you did, please give it a thumbs up. Please subscribe to my channel. Please like and share. Feel free to suggest any other alternative solution in the comment section. See you in the next video.